So friends, now after studying about the introduction of statistics, then visual presentation of data, then among numerical presentation of data, we have discussed about the measures of central tendency, then a series of lectures on measures of dispersion. Now it's time to start a new topic, that is on probability. So about probability, you might have learned many things during your 10th or plus 2 classes. So, but here we will study or we will discuss probability in a different perspective. So that this lecture on probability, I have divided into 2 parts. So this is the first part of the lecture on probability. So first we will see what is probability. So probability, it's a word probability is used to indicate the likelihood that some event will happen. So this word likelihood is very important. So it indicates what is the likelihood of happening of a particular event. So just listen it carefully. These are the examples that there is high probability that it will rain. So whether it will rain or not, that is different thing, but there is high probability. There is high chance that it will rain. Then comes the solar and lunar eclipses. You might be aware about the solar and lunar eclipses, and it is very well predicted by the astronomical calculations. So these calculations are based on the probability. Then case of tossing a coin. So this is very common experiment that you can do, and you are aware about that. The case of tossing of a coin. If you will toss a coin, you will either get head or tail. So that what you will get, that depends on the probability. So what is the probability of getting head and what is the probability of getting tail? Now the population growth and fluctuation of prices of a share or a stock. So this population growth, you might have seen a population watch. So what population watch indicates? This indicates that how population is continuously increasing. So how this watch is prepared? So it is based on the probability calculation. Similarly, the fluctuation of prices of share, that is also we can predict with the help of calculation on probability. So these are the certain examples where probability can be very useful. Now there are certain processes. So before coming to the actual probability, we will see certain terms or certain processes. So first, or what kind of event that is happening in and around us in our day-to-day life. So first one is deterministic process. What is deterministic process? If we can deduce laws, that means the process which is governed by certain law, which can clearly explain a certain process, and if we can exactly predict different results of this process on the basis of this deduced law. So suppose for a particular process you are having certain rules, certain laws, and based on those laws or based on the calculation of those laws, if you can predict result, then such process is called as deterministic process. For example, here you can see in this picture the deterministic experiment. Here genetic determination, that means there is rule. If a particular genetic combination you are having, you will have certain type of phenotype. Okay, so such type of process is known as deterministic process, which is governed by certain rule, and based on those calculation of those rules, you can predict the results exactly. Whereas another type of process is called as random process. What is random process? The process about which we cannot make exact prediction. So we cannot make exact prediction are called random process, and we have to perform repetitive experiments. So how you will know the result? How, whether there is any chance of prediction? So there is no chance of prediction. We cannot predict it exactly, but we can go in and around that event with the help of repetition of experiment. So if we are repeating the experiment, you can predict the result, probable result, but that result will not be the exact one. So we have to perform repetitive experiment to understand the nature of random process. So for getting the nature of that particular random process, you have to perform the repeated experiments. For example, suppose just see this experiment. So what it is telling, for getting random process, for getting the nature of random process, you have to perform random experiment. So here you can see a boy is just putting the arrow in the target, and whether this arrow will hit the target, no one can predict. And how we will predict it? How we will go around that? Just by simply repeating the experiment. So a number of times we will repeat the experiment, then we can understand the nature of this particular experiment, whether that will hit a target or that will not hit the target. So we will see it in future slides. So just see, for getting nature of random experiment or what is happening in the random process, you have to perform random experiment. So what is random experiment? The experiment performed to understand the nature and characteristic of random process is called random experiment. We have already seen. Now the phrases that is most likely, probable, quite likely, etc. are used qualitatively to indicate the chance that an event will occur. So in a random process or in random experiment, these are the phrases that will be most commonly encountered. What are those phrases? The phrases are most likely. Somebody will tell, it is most likely that today there will be rain. Most likely he will hit the target, or probably he will hit the target. Or it is quite likely that I will sleep today. So these are the words which indicate the chance that an event will occur. So probability theory. Probability theory is used to evaluate the uncertainty involved in those decisions. So in random experiment, how this random experiment, we have already seen that we cannot predict the result exactly. So but there should be some measures from which we can evaluate the uncertainty involved in that random process. So for that, probability theory will be of use. That is why here we are studying the probability, going to study about the probability. Now the actual definition of the probability. So what is probability? From the statistical point of view, the term probability is same as relative frequency. We have already seen the definition or procedure of relative frequency when we were classifying the data. So in classification of data, we have already seen the relative frequency. So the concept of probability is same as that of the relative frequency. So what is this? It measures the relative frequency of a particular event happening by chance. So what it measures? What probability measures? Probability is a measure of what? It is a measure of the relative frequency of a particular event happening by chance. So how a particular event, what is the relative frequency of happening of a particular event by chance? In other words, you can say that the measure of relative chance of occurrence of a particular event among the set of alternative. There are certain set of alternative, and what is the chance that a particular set will happen. So suppose, just a simple example, suppose you tossed a coin. So there are two set of alternatives. What are those two set of alternatives? Head and tail, head or tail. So what probability tells is measures the relative chance of occurrence of a particular event. Suppose you want to know the probability of happening of head. So head will be that particular event for which we want to know the relative chance. So we can deduce it with the rule of probability, and particular happening chance of occurrence of a particular event among the set of alternative is known as probability. So now we will see what is the range of probability. So with this definition that we have already seen, with that definition we can know that there are the probability will vary from 0 to 1. Why it will vary from 0 to 1? Because at the most what will happen? At the most either you will not get head or you will get head. Suppose you tossed a coin, if you are getting head, that means the probability of happening of head is 1. And if you are not getting head, that means the probability is 0. So the range of probability is between 0 to 1. Why 0 to 1? Since chance of occurrence of a particular event cannot exceed total number of possible events. So the chance of occurrence of particular event cannot exceed the total number of possible events. Suppose you tossed a coin. So what are the total events? Total events are 2. What are those 2 events? Head and tail. And what is the probability of happening of head or tail? So in relation to total event, probability of happening of head is 1 by 2. So that means chance of happening of head is 1 by 2 and chance of happening of tail is again 1 by 2. So if you are adding the chance of all these 2 events, so it will come around 1. It will come exactly 1. It will never be exceeding 1. That is why it is telling that value of probability ranges from 0 to 1, because the chances of occurrence of total event will be always 1. It will not exceed from the value of 1. So what is the next? If an event is certain to happen, its probability will be 1. Already I have told. Then similarly, if it is sure that the event will not take place, then probability of happening is 0. You can see in this picture, which is also known as probability scale. So suppose a particular event having chance of happening at 0. So that means impossible events. The event will not happen. So that is impossible. Then this is another example of tossing a die or throwing a die. If you throw a die, that means you might have played Ludo. So in that you may be saying it by different name, but here onward in English you have to tell it as a die, D-I-E, die. When it is single, it is called as DIE. When it is plural, there are a lot of so many die, then it is called as a dice, D-I-C. So here you see, in case of die, if you are throwing a die, there will be 6 possible events. 1, 2, 3, 4, 5, 6. But occurrence of a particular event will be the probability of occurrence of a particular event will be 1 by 6. Though the chance is 1 by 6. So this kind of event, on probability scale, it is called as unlikely. It is not sure whether you will get 1 or 2 or 3 or 4 or 5 or 6. So that is why that means the chances of occurrence of a particular event is very less. Then the third type of event, it is having even chance or equal chance, tossing a coin. So if you are tossing a coin, you will get either head or tail. So both are having equal chance. That is why it is called as the event which is having even chance. Then the next one is likely event. Likely event means what is the probability of getting 4 blue ball out of 5 balls. 4 blue balls are there and 1 red balls are there. So what is the probability of getting a particular blue ball if we are picking out a particular ball from the bunch of these 5 balls? So suppose you are having 5 balls, out of which 4 are blue and 1 is red. So what is the chance of getting 1 blue ball if you are picking 1 ball from that pocket? So the chance is 4 by 5. That means it is a likely event. It is a likely event because there are 4 blue ball and only 1 red ball. So whenever you will put hand in the bag, it is very likely out of 5 times, 4 times you will get blue ball. So that is why the event is called as likely event. And another one is the certain event. Certain event means only one event is there and that is certain to happen. So the probability will be 1. Probability for certain event which is certain to happen will always be 1. So hopefully the range of probability, why the range of probability is 0 to 1, you have to remember that range of probability is 0 to 1, but the logic behind why the range of probability is 0 to 1, it may be or it should be clear in your mind. Now, what are the statistical explanation of probability? So simply we learned the definition that probability is the chance of occurrence of a particular event in comparison to total number of event. So if you see statistically, if an event can happen in A ways, suppose a particular event can happen in A ways and fail to happen in B ways. A particular event is going to happen in A ways. A may be 1, 2, 3, 4, 5, 6, 7 or anything, and fail to happen in B ways. Then probability of happening is P. It can be given by P is equal to A divided by A plus B. So what is A plus B? A plus B is the total number of event. And what is A? A is the number of that particular event for which you want to know the probability. So it is otherwise known as favorable event. We will see in the coming slides what is favorable event. So A is the number of events occurring and A plus B is the total number of events. So what is probability of happening of A? It will depends on the ratio of A and A plus B. Similarly, the probability of failure of the event. What is the probability of failure of event? Here you can see the probability of failure of event is B. So the probability of failure of event will be Q is equal to B by total number of event A plus B. So this is how the probability can be explained statistically. Now again, if you elaborate more, then you will see that P plus Q. So what was P? P was A divided by A plus B, whereas Q it was B divided by A plus B. So if you will put these two P plus Q, so if you remember the range of probability, so probability ranges from 0 to 1. So if P is the probability of happening of particular event A and Q is the probability of happening of particular event B. So if P plus Q, it should be 1. If we are adding P plus Q, then probability of happening of a particular event and probability of non-happening of a particular event, it will always come 1. So here you can see A divided by A plus B divided by A plus B. If you solve it, you will get A plus B divided by A plus B, and then that means the probability of happening of event and non-happening of event will combinedly come to 1. So P plus Q is equal to 1, and in otherwise you can represent it as P is equal to 1 minus Q and Q is equal to 1 minus P. Hopefully it is clear to you how this P plus Q is equal to 1. Now there are certain terms which we are commonly using while studying probability. So that terms we will see one by one. So whenever you are conducting an experiment, you will get outcome in the forms of event. So it is better to know the different kinds of events that you are getting. So first one is simple event, compound event, equally likely event, mutually exclusive event, exhaustive event, independent events and dependent events. So these are the events that you have to see in the coming slides. So again, I will be repeating that while studying probability, you should have clear-cut concept of tossing a coin, then rolling or throwing a dice, and another thing about the playing cards. So you should know how many cards will be there in a deck, which color cards, how many numbers, this kind of concept used to be, it should be clear in your mind, and also the name of those particular cards. If you are having confusion in the name of the card, that is the English name, then there will be certain kind of difficulty while understanding the problems based on the playing cards. So the definition of certain terms. The first definition is trial. What is trial? So the experiment whose results are not unique. So those experiments whose results are not unique, that the results are not certain, even if repeated under identical condition, even if you are repeating the experiment so many times under same situation, under same condition, then also if the results are not equal, that is called as trial. So you can understanding it well by trial, sports trial. Suppose you are a player of 400 meter race, and so people commonly used to say that I am going for a trial. So why trial? Because in trial, even after repeating experiment, the result is not unique. There is always a possibility that result will be different. So that kind of examples are coming under trial. Suppose you are tossing a coin. So no one can say that even after repeating the experiment for 100 times, no one can say that it will be always head or it will be always tail. For example, tossing a coin or throwing a dice. So these are the trials. So that means in probability, the experiment is called as trial. Experiment whose result is not fixed is called as trial. So second term is event. What is event? So we have already seen, you have already get some idea of event. Here you can see the definition of event. Any possible outcome of a random experiment. Any possible outcome of a random experiment is called as event. So you have to mind it, any possible outcome of a random experiment. For example, occurrence of head or tail. So when you are tossing a coin, this is a random experiment and the possible outcome is head and tail. So this head and tail is called as event. Similarly, a newborn baby being a boy or girl is also an event, because there is no definite answer whether there will be boy or girl. In simple terms, so in simple terms you can say performing an experiment is trial and the outcome is an event. So whenever you are performing experiment, it is called as trial and the outcome, possible outcome, will be event. Then what are the exhaustive events or sample space? This is also very important. Many times we will directly use the sample space or exhaustive event. That is why you should have clear cut idea about these terms. So the total number of possible event. What is the exhaustive event? It is the total number of possible events. Suppose you are tossing a coin. So what are the total number of possible events? 2. What are those 2? Head or tail. There will not be any third outcome. So the total number of possible event in a trial is known as exhaustive event. For example, exhaustive event in tossing a coin, there will be 2, head and tail. Tossing 2 coin, if you are tossing 2 coin, so what will be the possible outcome? In one coin, head, another coin also head. Then another outcome, one coin head, another coin tail. Third outcome, what will be third outcome? First coin tail, second coin head. And another one outcome will be both the coins as tail. So if you are tossing 2 coins, the possible outcome will be 4. HH, HT, TH, TT. So if you are tossing n coins, what will be the possible outcome? So it will be 2 raised to n. So this formula you have to remember. So total, what will be the sample space? If you are tossing 5 coin, so it will be 2 raised to 5. What will be the possible outcome if you are throwing n dice? If you are throwing 2 dice, so what will be the possible outcome? 6 raised to 2, that is 36. So here you can say if you are rolling a single dice, in this picture you can say if you are rolling a single dice, the sample space, that is exhaustive event, will be 1, 2, 3, 4, 5 and 6. So these 6 events are known as sample space, and a particular sample space, particular event is known as sample point. Particular event is known as sample point. Now, what are the favorable events? So, favorable events, that is event under inquiry, an event about which you want to know. It is the number of events which entail to the happening of the event. It is the number of events which entail to the happening of event in a question. That means about which you are inquiring. Suppose a coin is tossed. A coin is tossed and you want to know the probability of happening of head. Then head is a favorable event. There will be chance of tail also. But since you want to know what is the probability of head, then it is called as favorable events. For example, the number of favorable events corresponding to the occurrence of at least one head in tossing 2 coins. So, probability of happening of at least one head. Suppose you want to inquire that 2 coins are tossed. So, what is the chance of probability of getting at least one head in these 2 coins? So, the answer is 3. Why it is 3? Because out of 4 possible outcome, in 3 there will be at least one head. So, these are the possible outcomes where you will get at least one head. That is H1H2, H1T2 and T1H2. So, the favorable event means the event about which you are inquiring. Now, what are the equally likely events? So, 2 or more events are said to be equally likely if one cannot be expected to occur in preference to other. That means the two events which are having 2 or more than 2 events which are having equal chance of occurrence. One event is not getting favored. So, such kind of event is known as equally likely event. For example, suppose you are tossing a coin again. So, in case of a balanced coin, that means you have not manipulated the coin. So, in case of balanced coin, the event head or tail are equally likely event because the chance of occurrence of head and tail is equal. You cannot prefer head in comparison to tail. So, but suppose a coin is waxed on one side. Then event of occurrence of head and tail are not equally likely because there will be favoritism for a particular event, either head or tail. So, such events are not equally likely. But if the chances of occurrence of both the events or any of the events is equal, then it is called as equally likely event. Then simple and compound event. The occurrence of a single event is known as simple event. Suppose there is a single event, then it is also called as simple event. But when 2 or more simple events occurs in connection with each other, if 2 or more simple events occurs in connection with each other, their joint occurrence is known as compound event. So, if you see example, we will be understanding it more clearly. So, what it is trying to tell that if one event is occurring singly, then it is simple event. But if 2 events are going to happen in connection to each other, then it is called as compound event. How? What is an example? Here we will see in the next slide. So, for example, if from a pack of cards, you are having a pack of cards, a king is drawn. Suppose from a pack of cards, so in a pack of cards there will be 64 cards. If you are drawing king, then it is a simple event because it is a single event. If you are drawing queen, it is also a simple event or single event because it is a single event. But suppose what is the joint occurrence of both king and queen? Suppose you want to know the joint occurrence of both A and B, that means king or queen. What is the probability that either king or queen is drawn, or king and queen both are drawn? Then drawing of a king or queen both are called as compound event. So what is the probability if you pick two cards from a pack of cards? What is the probability that both king and queen, you pick both king and queen? So this type of event is known as compound event. Another one is mutually exclusive or disjoint event. Mutually exclusive, disjoint, joint and disjoint. So in word itself, the definition is clear. Events are said to be mutually exclusive when they cannot occur simultaneously. If a particular event, if two particular events, if events are not occurring simultaneously, how it will not occur simultaneously? Suppose you tossed a coin. So it is not possible that both head and tail will come together. If head is coming, there will not be tail. If tail is coming, there will not be head. So such kind of event is known as mutually exclusive event. In other words, the occurrence of one event excludes the possibility of occurrence of others. That is why it is called as mutually exclusive. If any one outcome happen, all other fail to happen. If any one outcome happens, all the other event fail to happen. So such kind of event is known as mutually exclusive event. All simple events are mutually exclusive. All simple events are mutually exclusive. Suppose this is the two coins. A represents head and B represents tail. If A is coming, there will not be B. If B is coming, there will not be A. So same example, if a coin is tossed, either head or tail can occur, but both will not occur. Similarly, in throwing a die, suppose you are throwing a die, all the 6 faces are mutually exclusive. Why? Because if you are throwing a particular die, if there is one, all other 5 events will not happen. If there is 2, rest of the events like 1, 3, 4, 5, 6 will not happen. So this is the example of mutually exclusive event. Now another event is the independent event. What is independent event? Suppose 2 events are happening together, but one event is not getting affected with the happening of another event, then it is called as independent event. So just we will see the definition. A set of events is said to be independent if the occurrence of any event does not affect the chance of occurrence of any other event. Chance of occurrence of a particular event does not affect the chance of occurrence of any other event, then it is called as independent event. So with example it will be more clear. Suppose for example, when two coins are tossed together, previously we had seen if one coin is tossed. So if one coin is tossed, if there will be head, there will not be any tail. But suppose if 2 coins are tossed simultaneously, then the occurrence of head or tail in the first coin does not affect the probability of occurrence of head or tail in the second coin. Suppose first coin there is head, then in second coins it is no way related with the first coin, outcome of first coin. That means if in first coin you are getting tail, in second coin you will get anything. It is not related with the happening of first coin. So such kind of event is known as independent event. So its counterpart, when we will see about the dependent event, then it will be more clear. Okay, what is independent event, what is dependent event. So the next one is dependent event. What is dependent event? When 2 or more events are said to be dependent if occurrence of one affects the occurrence of another. If the occurrence of one event is affecting the occurrence of other, then it is called as dependent event. How? Just we will take one example. If we draw a card from pack of card, so we are having a pack of card and we are drawing a particular card, and then another card is drawn without replacing the first card. So what is there? We are having a pack of card. So we drawn one card, one. Then we drawn another card, two. So what is there? The point is that we removed one card, and then we removed another card, card number 2, without replacing the first card. That means once a card is removed, it will not be replaced. So in such case, the drawing of second card is dependent on the outcome of first card, because whatever card that has been drawn for the first time will not be drawn for the second time, because the event has already happened. So one will not be repeated second time. So such kind of event is known as dependent event. For second event, it is dependent on the happening of the first event. That is why it is called as dependent event. However, drawing of second after replacing first card make the second draw independent of first one. So suppose if you draw first card and then replace it, that means again you put the first card into the pack, and then you draw another card. So the drawing of another card is now not dependent on the drawing of first card, because you have already replaced the first card. You have already put the first card back into the pack. That is why it is not depending on the happening of the first event. So this second example, it is the case of independent event. So hopefully dependent and independent events is clear to you. It should be clear. If it is not clear, you go read certain books, or you will see certain video in your YouTube or in certain write-up, then it will be more clear, or you just carefully listen this, it will be clear. Now, before reaching to the types of probability, I want to say that why we are studying probability in the course of animal genetics and breeding, because the principle of animal genetics is mostly working on the principle of probability. So what is happening in our system, biological system, is following the principle of probability. Why? Because you might have studied meiosis. In meiosis, you are seeing everything is the exchange of genetic material between the two gametes is totally depending on the chance. That is, it is working on the principle of probability. That is why the study of probability is very important. You will realize when you will study the genetics portion, how the gametes are getting fused and how genes are getting exchanged, and what will be the outcome, that will be depending on the probability. So now we'll see what are the different types of probabilities. So first one is the mathematical or classical or a priori probability. A priori probability. So what is mathematical or classical or a priori probability? Mathematical probability is based on the assumption that the sample space, what is sample space? Sample space is the total number of outcomes. We have already discussed. That is exhaustive event. If sample space, that is exhaustive event, total number of event is finite, and the elementary event are equiprobable, that is equally likely event. So if the sample space or possible outcome is fixed, finite, we can count, and the events are equally likely, then this kind of probability is known as mathematical probability or classical probability or a priori probability. It is obtained on the principle of differences or insufficient region. So this is mathematical or classical or priori probability is obtained on the principle of indifference or insufficient region. That means the possible outcomes are finite and all the events are having chance, equally likely chance. So next, in case of tossing a coin, suppose the example of this mathematical or classical or a priori probability. In case of tossing a coin, throwing a die or drawing a card from a pack of cards, the probability are calculated on deductive reasoning. So for such classical or mathematical or a priori probability, you are having prior knowledge of sample space. Why? If you are tossing a coin, you know the sample space is 2, head and tail, and the chances of occurrence of head and tail are equal. So based on certain calculation, deductive reasoning, you can find out the results, probability of result, even before the trial. Even before the trial, even before the experiment, you can know the possible outcome, probability of outcome, because the sample space is fixed and the event is equally likely. Since why we are able to know the result by deductive reasoning? Because we have prior knowledge about the probability in such cases. It is also known as a priori probability. Here we obtain the probability of the event under the assumption that outcome of these are finite and events are equally likely. So whenever somebody is asking what is mathematical probability or classical probability or a priori probability, that means you have to tell that the total number of sample space is finite and events are equally likely. We are having prior knowledge of total number of event or possible outcome. So that is why it is called as a priori probability. Now we can define the classical probability as below. So we'll go in more detail about the classical probability or a priori probability. So just in formulative term, you will see if an experiment results in n exhaustive, equally likely and mutually exclusive events. So you are having n exhaustive events which are equally likely, and m of them are favorable. So m is the favorable event and event is known as E. Then the probability of happening of an event, is P. What is the probability of happening of event? That means P is equal to the ratio of number of favorable events. So what is the ratio of number of favorable event? The ratio of number of favorable event is M to the exhaustive number of events. So what is exhaustive number of events? It is N. So it will be more clear in the next slide, because in next slide we have written the formula. So mathematically you can see the probability of event E is equal to ratio of favorable events, chance of favorable event, that is M, to the total number of exhaustive events, that is N. So P of a particular event is equal to M by N. M is the favorable event and N is the total number of events. Further, since the number of events favorable to non-happening of the event are N minus M. So what is the chance of non-favorable event? It is because the total number of event is N and number of favorable event is M. So that is why unfavorable event will be N minus M. And what will be the chance of happening of or non-happening of favorable event? It is Q is the chance of non-happening of particular event. It will be N minus M divided by total number of event. So otherwise you can say, because it will be equal to 1 minus M minus N. If you will solve this equation, you will get 1 minus M by N. Why? N by N is equal to 1 minus M by N. So this is the chance of Q is equal to 1 minus M by N. Or you can say this is equal to P. That is why it will be equal to 1 minus P. So P plus Q is equal to 1. That means the happening of event and non-happening of event is together will come to 1. We have already discussed in the first portion also. So now you can say 0 is less than or equal to P is less than or equal to 1, and also 0 is less than equal to Q and less than equal to 1. That means the range of probability is always 0 to 1. It will never exceed 1 and it will never go below 0. So this is about the mathematical concept of a priori probability on mathematical probability. Now the second one is the statistical or empirical probability. Statistical or empirical probability. So it is applied in most of the research field in many biological problem. So you can see here is a biological problem. In many biological problem, it is not possible to determine all equally likely cases before actual trial. So in many of the experiment, many of the biological experiment that we are conducting in our course in veterinary field or even in any biological field, if you are conducting experiment, before conducting experiment, you cannot say what will be the possible outcome or whether that event will be equally likely or not. So such kind of probability is known as statistical or empirical probability. Statistical or empirical probability. So here, in case of a statistical or empirical probability, the probability is determined from a set of observation. So how probability will be determined? After the conduction of experiment from the set of observation. How? Example, in a random sample of 100 individual, suppose just I have taken the example of blood group. So in a random sample of 100 individual, suppose 5 individuals are found to be AB blood group, giving us P is equal to AB, because we want to know inquire about the AB. So what will be the probability of AB? The probability of AB P is equal to 5 by 100. 5, what is 5? 5 is the number of happening of favorable event divided by total number of event, that is 5 by 100 is equal to 0.05. We cannot get the probability of AB blood group individual unless a random sample is studied. So without studying a sample, you cannot say what is the probability of getting AB blood group. This estimate of probability is known as statistical or empirical probability. So in case of biological event, you have to conduct experiment and then based on the outcome of experiment, you can determine the probability where which is known as statistical or empirical probability. Whereas in mathematical probability or classical probability or a priori probability, you are having prior knowledge of sample space and total number of event or favorable event. Then you can say the possible outcome before conducting the experiment. So this was all about the classical and statistical probability. Now in the next class we will see the law of probabilities and certain other things on the probability. So if you are having any confusion in the regarding the probability, the portion that I have covered today, you can ask me from any medium. You are having mail, you are having my number, and even you can comment here also. So thank you.